Okay, so we have been seeing virtual machines, right? Like whatever our AWS EC2 machines we are spinning up, they're all virtual machines, right? And what is physical machine? So in our example, real-time scenario, so we can take our laptop as a physical machine. Okay, so previously, so when this computer generation started, so everybody has a physical machines, right? So after that, virtual machine evaluation happened. So why virtual machine happened, and now why people are using Docker? So let's a little bit understand on all these concepts. Okay, so let's say this is your physical machine. Where is I noted? Okay, so this is your, let's say this is your physical machine. Physical machine, nothing but it has a CPU, it has a RAM, it has a disk. Let's assume only these three main parts. Okay, and this is CPU is 8 core CPU, 24 GB RAM, and let's say 500 GB hard disk. Okay, so if you want to install an application, okay, you can install in this. So once you install it, it will have an IP address. Using IP address, you can access your application. That's it. So if you want to run one more application in this, you may not, because that IP and that port is already reserved for your application. So technically, your application just uses like two CPUs, okay, and then 8 GB RAM. It just needed 100 GB hard disk. That's it. So whatever remaining resources are there, they're all waste, right? So because you cannot reuse those, they're unnecessarily sitting in your machine, not being used effectively. To do that, to effectively use that, so there is a concept called virtualization. So what is virtualization? So you have a same machine, same physical machine with same CPU, same disk, same RAM. Okay. So this in this machine, you are going to install a hypervisor. So what is hypervisor? So hypervisor is nothing but your VMware or VirtualBox. So you can also install it by downloading from the Google right now. Go in Google, do VirtualBox, you'll get it. Download it. So once you download it, you can install it. So after installation, it will provide you a flexibility of creating virtual machines. So they are all virtual machines taken resources from your main hard disk, your main physical machine. Okay, so let's suppose this is your thing. Okay, so here you have 8, 24, 500. So this is your machine. Okay, so on top of this, you will have your operating system, Windows, Linux, or Mac. So here you have installed the VirtualBox. Let's suppose VMware or VirtualBox. So this is the hypervisor. Okay, so on top of this here, so this VirtualBox will let you spin up VMs. As many VMs as you want, you can spin up. Okay, so what is this VM and how does configure it? So this VM, let's suppose you needed this configuration for your application. So you can create a VM with this configuration 2, 8, and 100. So your remaining still have 6, right? 16 and 400. So that you can allot to this. So you can allot VM2 as again same 2 CPU, 8 GB RAM, 100 GB disk. Again third VM, same 2 CPU, 8 GB RAM, 100 GB disk. So now you see, technically you have your one OS. This is one machine. and then you have machine 2, machine 3, machine 4. So you can spin up 4 machines. So you can spin up one machine for Jenkins, second machine for agent, third machine for your deployment dev environment. So your laptop technically can be converted into multiple machines. This is the hypervisor. So now you see, perfect. Again, when you talk about virtual machine, okay, so virtual machine is nothing but a replica of your operating system. So it should contain all the packages, all supported kernel, all supported OS stuff, right? That is okay, because still we are able to divide our machine into multiple machines. We are using it. This is perfect. Okay. So any doubts on this?
No.
No. Okay. So now let's talk about one more. So now here, this is what we have seen right now. So this is your bare metal. This is called the bare, let's have physical, CPU, RAM, and the disk. So let's call it as a blade. Let's assume. Okay. So this is your operating system. This is your hypervisor, and this is your machines. Okay. So even you see this OS, this part of OS. So even this OS needed some resources, right? But you are not technically using this, because when you have virtual machines, you can use virtual machines. So technically you don't need the OS. But physical machine, like let's talk about laptop. Yes, you need an operating system initially to boot up, because you have to bring up the screen up, right? So you need OS. But if we talk about the big industries like AWS, Azure, Google Cloud and all, or maybe some big companies who are maintaining their on-prem data center, okay, so they don't need that OS layer. So what they can do, they purchase a big blade, they call bare metal. Okay, so this could be like uh, 200 CPUs, GB RAM, and then 1 terabyte. So storage comes from different storage array, but let's assume, so we have it here everything. Okay, so you have this much of blade. They don't have an operating system on top of this, because OS also kills some resources. So what they do, they directly install hypervisor on it. So this hypervisor again spin up the VMs, as many VMs as you want. So you can allot the size accordingly. So remember, so we have been spinning up the machines, right? EC2 machines. So this is what our AWS is doing. It is, let's suppose if I ask for AWS to spin up a VM, this is giving me this VM from this blade. Okay, if you also ask at the same time, it will spin up another VM from here. So if Sangam spins up, so he gets his VM here. Okay, so if this blade is full, if this metal completely full, so they might be having some thousands of metals like that, thousands of hardware. So the VM will be spinning up based on the resources. So if I ask them to spin up a 2 terabyte VM, so 1 terabyte VM is a capacity, 1 terabyte is capacity of this blade. So there could be some 2 terabyte, 3 terabyte disk is there. So in that hardware, my VM will be spun up. So this is how the virtual machine concepts. Okay. Again, if we talk about a VM, okay, so whenever you spin up the VM, so what packages you get? You get all the kernel, all the OS supported packages, you get systemd, that means services, and you get maybe curl, and you maybe get some OpenSSL. So there are so many packages. So these packages together makes an operating system. Okay, so this operating system can be AWS, this can be a RHEL, and this can be a Debian, because OS actually sits inside your virtual machine. So once the VM is created, so you can choose which OS you want to install. Okay, this is the concept. So each and every VM have all these packages like together packages. Okay, so now let's spin up a VM first, and then we see why we use a Docker over there. Okay, so maybe I'll explain it here itself. Okay, so now we have got a VM, right? Okay. So this VM contains so many packages. Like you do ls command, it works, right? You do cat command, it works. You do sudo command, it works, right? You do systemctl, right? You do yum, right? So whenever you execute a command, all these commands are working. So working means the corresponding package is available in the VM. That is the reason the commands are executing. So if you don't have the curl, what you will do? You will install the curl again. The curl will be here. Then you can use a curl command or wget command. So each and every command is actually contain some package, some binary, some source code. Okay, so that will be kept in your VM. You may use it, you may not use it, but if you want to call an operating system as an operating system, then you have to have some minimum basic softwares, that's packages, that's the commands. But technically speaking, you just need to install your application. You just need to install your application. To do that, what you need a space. Maybe you mount it to here /opt. Okay, you need Java because yours is Java application, right? What else you need? Nothing, because the more than once you execute Java minus jar and your package, okay, your application will be up. That's it, because JVM will take care of running your application. So do you really need the curl command here? Do you really need the yum packages here? Do you really need the sudo here? The cat commands? So these are all technically you don't need. To run your application, you just needed one mount point and then one software that will run my app. So again, these are all packages on burden. So to remove that and to only give the packages that you wanted to run, the Docker come into the picture. That is called the containerization. So whatever you needed, you only get those. That's what the thing is. Okay, so if we talk about a typical scenario, okay, you are feeling very hungry, okay, damn hungry. Okay, so if you want to eat something, what do you need? So you need gas, you need house, you need a kitchen area, you need to buy ingredients, you need to cook, right? So these are all required for you to eat. Okay, so what if you just need to get eat? So you get food from outside, right? And you heat it in microwave, it gets heated and you eat it. Is it same or not? You just wanted to eat. You are hungry. You want to kill your hungriness. Either you can go and buy ingredients, buy a house, put a kitchen, put a stove, cook it, and eat it. So this will give you a process of cooking to kill your hungerness, right? The same thing, you have a microwave, you get the packaged food, you come home, heat it and eat it. Does it kill your hungerness or not?
Yes.
Right? That is what the purpose. So if we talk about physical machines, virtual machines, it is like you're doing entire stuff. With the Docker, you just need to kill your hungerness. You are hungry. You just go buy a chicken biryani, you come home, heat it and eat it. That's it. You want to eat mac and cheese, get the micro mac and cheese, put water, heat it. So to kill your hungerness, so what you all need, you just need a microwave and a power. That is what the Docker is. You don't need a house, you don't need a kitchen room separately, you don't need utensils and all. Whereas virtual machine concepts, again, you need to have a house, you need to have a bedroom, you need to have a kitchen, all this. Do you really need all those? No. That's what the differentiate in our layman terms. Docker is only thing to install that is required by your application, whereas virtual machines will give you a luxury of running an entire OS that you can install and uninstall, whereas physical machine, actually that is the one who provides us the resources. Like physical machine means, so you have a complete house. In that house, you separate it. That is the bedroom is one virtual machine, reading room another virtual machines, kitchen another virtual machine, backyard another virtual machines. So these are all different purposes. So you can use one house, and you partition all these. That is called the virtual machines. So if you really want to sleep, you go to the bedroom. If you really want to cook, you go to the kitchen. That is how you categorize your physical machines into virtual machines. So now again, if you really want to eat, you don't need to have a full kitchen setup. You just need a simple microwave. That is the Docker. Again, if you really want to sleep, you don't need a complete AC and bedroom and everything. You just need to lay down, you just need a small floor or bed, small bed, right? That's again Docker purpose. So that is what the Docker. It will just give you what is required for your application to run. Okay. So now let's go ahead. Again, if you really want to cook microwave, you need to place the microwave somewhere, right? Where are you going to place it? You are going to place it in the kitchen. That's again one virtual machine, right? You need a power supply. You need some resources. So it is taking a resource from your virtual machine, your kitchen, and your kitchen is part of your physical machine. That is called the blade. So your blade is giving you all the resources to virtual machine, and then virtual machine passing the same to your Docker. That's what the Docker concept here is. Okay. So any doubts on this?
No.
So you may see once we jump on to this. Okay. So I'm going to spin up a machine now. Okay. So Docker can be installed in a physical machines or in virtual machine as well. Okay. So now let me go ahead and bring up a new machine. I'll probably take the Debian one because it's easy to install. Okay. So I'll pick up this Ubuntu. We need some bit more resources for this. For the today's practice, I'll go with this T2 Micro. Okay. I'm going to use my key. Okay, this guy is running. Let's copy this. Oh, it's not ECD user, right? It's Ubuntu. Okay, so I'm inside the box now. Okay, so now this is a virtual machine. So we got it from one of the hardware that is AWS is maintaining. Okay, so in this virtual machine, now I'm installing the Docker. Okay, so I have a curl available here, right? I have a ls available here, cat available here, vim available here. So these are all packages. So these all made up a house. So if you really want to buy a house, so you look for a kitchen, you look for a bedroom, right? Minimum. So if you have those, then only call it as a house. The same way here. So now let's go ahead and install our Docker. Okay, apt install. Sorry, sudo. Updating the apt cache. There's the instructions here available. How to install the Docker. So first we need to set up the repository. We need to install the required packages and then download the key file and then install it. So let me follow the same instructions. Sudo. This is what we did already, I think. And then second is this command. And then this guy. It's just like a fingerprints check. Okay. Now we're adding a stable one. We're updating the packages one more time here and then finally installing the Docker. So Docker CA, Docker CLI, container D, IO. Okay. So this is the Docker CA. This is the one actually installs your Docker. This is CLI. This is a new thing. I don't know, container D. Let's install all this. Okay. So now we have installed the Docker. You want to see, we can check with docker dash version. So we have Docker version 20.10 is installed. Okay, so we need to bring the service up. Okay, so let's check. This is Ubuntu. I use the service command. Service status Docker. Sorry. This is service Docker status. It is active and running. Okay, so I have a Docker running. So how can I check if Docker running or not? You need to do Docker PS. It says permission error because Docker need to take the resources from your VM, right? So it has to read your network, it has to read your CPU, it has to read your memory. So these are all actually admin tasks, not a regular user task. So that's why the Docker will only be executed by the resources who have access to sudo. Okay, so users with sudo privileges can execute the Docker commands. So if I do sudo Docker PS, I got some output, no error. Okay, otherwise, so in a typical scenario in a company wise, so you generally don't grant sudo access to each and every user. If a particular user wanted to use a Docker, then we don't provide him the complete sudo access. Rather, we just add that user to the Docker group. Remember, this can be an interview question. How do you grant access, a Docker access to a normal user? There are two ways. And the best way is adding that particular user to a Docker group. There is a group called Docker. You need to add that user to the Docker group. So after that, the user, once he relogs in, he gets access to Docker. That's the first and best option. Second option is give him sudo access. That is a bad practice. So don't give that. So the answer is you give that user Docker access by adding him or her to Docker group. Okay. So now Ubuntu is a Docker, right? So I switch to root here. Okay. Now let me add Ubuntu user to the Docker group. That is command is user mod -a append -g. The group is Docker. Who is a user? Ubuntu. Done. So now user is added to Ubuntu group. So Docker group. So we have this user and this user. Okay. Now let me log out session one more time. Now let me do Docker dash version. There, Docker PS. See, I got the access. So before it was giving me an error message. So when I do Docker PS, got permission denied message. So what I did, I added the user Ubuntu to the group Docker. So -a means append. This is a group. So now Ubuntu is part of two groups. One is Ubuntu group. Second one is Docker group. So that's why after he relogs in, he was able to execute the command. That is how you grant access to a user. Okay. So now we are good. What is next? So we are feeling hungry. So we need to cook, right? We need to cook. So how do we cook? We need to buy something from outside. Perfect. Let me buy something from outside. So where I will go? So there is a Docker hub. Okay. So if you go to docker.hub.docker.com, you will see all preloaded images. So remember, so whenever you want to spin up a VM, okay, so where do we go? We pick up an image, right? So EC2, if I go to the EC2 package, so launch instances. So when you try to launch an instance, this will ask you to pick up your image, right? And these are all image. So what is this? Amazon Linux image. It means this image contains Amazon operating system. So if I pick this one, so this image contains your Red Hat operating system. So this image has a packages that supports Red Hat operating system. How about this? This supports your Debian, Ubuntu, right? The similar way, Docker also has a operating system, but it doesn't need all the required packages to be there. It doesn't need all the packages to be available. It just need a file system and the basic operating system files. That's it. So that images are available in the Docker Hub. So you can sign it up if you have access. I have access, so I can log in. So recently Docker Hub has modified some changes that only authorized people will download with a limit. So they put a limit now, how many downloads you can do in a day. I think it's 600 or 200 is there. But our practice, we don't need, we can directly search here. So let's suppose which application you want to run. So we have been doing HTTPD, right? Let's say HTTPD. So there is one available. I'll open this HTTPD. These are all details. Okay. So how do we do? There is a command. Run the command. This is the, they say like this, docker run -d it. There are some instructions how to do this. Okay. But this requires some changes for you. Maybe I'll pick up the Nginx one. Okay. That's EG. I'll open the Nginx. So have they said anything? Yeah. So they say run this. They're asking to mount some HTML as well. I want the stuff that yeah, let's see without HTML and see how do we run. Okay, so this is the image that we need to use. So what is Docker pull Nginx? This is like you are ordering the food. So I want Nginx food. So how do you image? Docker pull. So you are pulling the image from the Docker Hub. Okay, so now let me go ahead and do that. Say Docker pull Nginx. This is the command, right? So I enter it. Now see what happens. So it is downloading the image. The image got delivered. Now what we need to do? We need to heat the food, right? In a microwave oven. So how do we heat the food? The command is docker run. So docker run will actually run the container. What is the container name? Nginx. Okay, so this is what they have informed us to run. Docker run, they give some name, this. Okay, so the thing is here, docker run Nginx. Okay, I run it. Let's see. It says ready to start up. It is started actually. It has started. But it is seeing, right? I mean, the cursor is not coming out. So if you want to run this in a backend, you need to use -d parameter. I stop this, it is done. If I do docker ps, I don't have anything running. If I do docker ps -a, this shows some information to me. So -a means all. What it is showing here? I have a container ID. The name Nginx is the image. This is the command was run when the image is run. 34 seconds ago it created. Current state is exited. It died. What is died means? Died means it is completed. The purpose of you bringing a container is completed. And the name strange something Babbage. The name every container whenever you spin up, the Docker by default allots one strange name, the default name. This you can ignore, not important. The important stuff is the container ID and the status. Okay, so it started but died. Now let's again run this in a backend. So the backend running is same command. You just pass -d here. Okay, now it ran in background. You gave your console back. Now I do docker ps. See, it says up 5 seconds. It is up and running. And you see ports here. It is running in 80 port. Perfect. So it means my Nginx server is running in a container. So when you docker ps, give me container, name is this command got executed 6 seconds ago, it is up. So port is 80. So this is what just happened now. So this is your machine. Okay, you have an operating system, that is my Mac. Sorry, this is AWS, right? So they have directly hypervisor here. Okay, so they gave me a VM, Ubuntu VM, and this size is 2 GB RAM, right? 2 GB RAM, 10 GB hard disk, and one CPU. Okay, so what I did, so in this VM, let's suppose in this VM, I have installed a Docker engine. I created a Docker container, and this is Nginx, right? So now this is up and running. So now how I can access a service running inside the container? To do that, your container will expose the service in one port, whatever the application is defined inside the container. Okay, if the application is running in port 80, it is 80. Okay, you cannot access that container port because your VM is the only way of communicating, not the container. So like this. So let me clear this, make this bigger screen. This is now here. So this is your VM. So this VM have an access 22 port, right? So that you can access SSH, that we did it. So we installed the Docker here. Okay, so Docker is running the container now. One container, only one at the moment we have. This is up and running. Another container was died before, right? That don't forget about that. So this is a container running now. So inside this, the application is running on port 80. So how do I access this? Because the only way you can access is this VM with IP address on port 22. So if you want, you can only enter with 22. You can access the SSH, but you cannot access the container. You cannot get into the container. So how do I do that? To do that, you need to expose the port from your VM as well. Let's suppose I have a port 80 here. So again, I am going to open up port 80 on the VM as well. And then I'm going to inform Docker that if someone access this IP1 with port 80, then you send the traffic to this container. That is called exposing. I'm exposing my container with port 80 so that people from outside can log in, can access me with port 80. Okay, the same way, just stay with me. Now I'm going to run one more container. Okay, so this is running on port 8080. Maybe this is Jenkins. This is Jenkins. I cannot access because it is running inside a container. So if you want to access this, I need to open up a port. So I can use 8080. So now if the people who want to access, he can use the IP address, IP of this colon 8080 will take me to this container. Okay, I have one more application I wanted to install, that is HTTPD. This is also running in port 80. Yes, so you can have container running on same port, right? Now what happens? Again, if I want to access my HTTPD, the third container, I need to open up a port on the VM. So how do you open the port? Which port do I need to open? So my container is running on 80, right? I have to open it 80. Now what happens if you open with 80 again? So your VM will not support same port numbers opened. It can only support one port number, unique port number. So this 80 is already registered. So whenever someone access with 80 port, so this will send the traffic to container 1, which is Nginx. So again, I have to choose a different port. So I can choose 8081. Now, whoever access 8081, so their request will be now routed to this container. So don't get confused. The container port is different. The host port is different. The host port is a way to enter into the machine. So once you enter into the machine, your Docker knows where to transfer that traffic. So if somebody accessing your VM on port 8081, your VM knows where to send the traffic. It is like a load balancer. So you have a load balancer, you have a 8081 group, 8081 another target group. Whenever someone access your load balancer with port 8080, it goes to one target group. If the same user access the same load balancer with port 8081, it sends traffic to another target group. The same applies here. Your VM on port 80 sends traffic to container 1, 8080 sends traffic to container 2, 8081 sends traffic to container 3. So inside the containers can run on same port. There is no issue because they're all individual. But outside, if you want to expose it, if you want to access externally, then you need to open up a port, and that port has to be a unique. You cannot use a duplicate one. Okay, this is what. So now we brought the Nginx container up and running, right? But we haven't seen it. Okay, now let's go ahead and access it. How do we see that port? We clear all the diagrams. Okay. Okay, so Docker PS is running now. It's running on port 80. Okay, so let me kill this. I killed it. If I Docker PS, it is gone. So now let me run it again. The same command that we have done. So Docker run Nginx will run it in a foreground. But if you want to run it background, we use -d. So now we want to expose the port. The command is -p. That is the port. Okay. So first we need to provide the container port 80 colon. So on VM, which port you wanted to assign? I want to assign to same 80 port. Okay. So if you want to give a unique name, you can also give. So I'm going to pass -- name as well, minus name. I'm going to say my Nginx. Okay. Now run it. Says running. If I Docker PS, now you see. Now port says anyone with port 80. When they access, the traffic will go to the container 80 port, and the name is my Nginx. Now let's go ahead and access our application. So I go back to here. This is my machine, EC2 machine. Docker. I'm just opening up the port here. Because you cannot access VM, right? So you need to open a security group for the port number 80 to access it. Add a rule, HTTP, yeah, port 80. Anyone can access it. Save the rule. Go back to EC2, get the machine's IP address. Come on. Your public DNS. I copy this. Port 80. You don't need to mention. See, welcome to Nginx. So my Nginx is running inside the container that is running in a VM, and VM is coming from a bare metal. This is what the Docker. So did we install the Nginx packages? No. Did we configure? No. Someone else configured and we just used it. Just like someone else prepared the food for us, we ordered and we ate. Right? This is what it is. So now let's run HTTPD as well. Okay. Now let's see if I can run the HTTP directly without installing any packages. Now I do HTTPD. This is my HTTPD. This is what I need to do. Docker pull HTTPD. I copy this command. I go here. I pull the image first. Image is pulled. Now let's run. What is the command? Docker run. We need to use -p. So again, HTTPD is also running in a port 80. Or maybe let's run directly first. Run -d. And then what is the, I give the minus. Let me give the minus name as well. Name. This is called HTTPD. And then image name HTTPD. Okay. So I ran it. If I do Docker ps, I have two applications running. You see. So even this is also running in port 80. My Nginx is also running in port 80. So I cannot expose this container on a host 80 port. It says duplicate already used. So you want to see? Let's see. There is a command to expose. I think Docker expose. There is a command to expose running container. Okay, this is what it says. Maybe I'll kill it. I don't want you guys to get confused. So now we know it's running on port 80, right? So I just kill that process. This is HTTPD. Docker kill this. It is killed. I have all Nginx running. I do the same. So this is, I give my HTTPD name. Now I give -p port. Okay. It was running on 80, right? So I also use 80. Now let me try to expose on same 80 port. Let's remove this name as well. It's a duplicate. Okay, now let's run it and see what happens. So you got the error. It says driver failed programming external connectivity and endpoint substitution because the port is already allocated. So the VM on port 80 is already allocated for Nginx. So we cannot use that. So now I need to use a different port. So I use 8081. It's my wish. Oh, this is a host port, sorry. 80, 81, and 80. Yeah, this is the host and this is the container. So if I do docker ps, so now I have 80, 81 is routing to 80. Now let's go ahead and access my application. This is my IP, right? So I go here and then I type 8081. I cannot access because I need to open up the security group for this. So it is blocked. So now again I go back here. Come on, why it's so slow? So I go to security. So currently we have only 8081. So what I'm going to do is I'll just open up for entire so that we don't need to all the day come and edit this. I'll open up it for all the ports. So add rule, I would say all TCP. So who, but here we need to be a bit secure. So we shouldn't provide our 00 because everyone can access it, right? So I'm going to provide only my IP. This is my IP. I'm going to assign this. Yeah. So now if I go ahead and access my see 8081, it says works. So now technically in one VM, I was able to install Nginx application and HTTPD application. I can also install Jenkins in this. You wanna see? Let's install the Jenkins as well. So for that, I'm going to do what is that? Docker Hub, right? Or here. So let me download the Jenkins container. I think this is not the right one. It's a Jenkins CI, I think. Jenkins CI, Jenkins. This is the right one. So I'm copying this and run it. Docker pull this guy. We may end up resource issue now. Okay, so this is done. Doc in Jenkins is pulled. Now let's run it. So how do we run it? There are some instructions on how to run this. For documentation, they say to look this page. So we need to use this to run. Okay, they're exposing minus P 8080 8080 here, and they're exposing two ports. This is the Jenkins. Okay, so now let me go ahead and run this image. I would go ahead, docker run -p. I need to run it in background, right? So I'm going to use -d as well. -d -p. They say 8080:8080. One more port, that is 50,000 colon 50,000, and the image is this. Okay, you wanna give a name? Yes, let's give a name as well. Name, I would give Jenkins. Yeah, it's running. So let's do docker ps. You see, I was able to run Jenkins and HTTPD and Nginx in one machine. This is how we use Docker. So if you want to see the logs, you just select this container ID, you do Docker logs, and this, it says setup completed. It's up and running. So now I can access with 8081. So I copy this guy, sorry, 8080. I go here and then 8080. There you go, my Jenkins. See, one VM, 3 different applications, HTTPD, Nginx, and Jenkins. So maybe Jenkins need 1 GB of RAM. It can only use that one. Nginx use 1 GB RAM. HTTP needed 1 GB RAM. So only 3 GB allotted. So if my VM is having 8 GB, I still have 5 GB of RAM to use. So let's keep 2 GB for OS. So I still there 3 GB to use. So I can install 2 more applications. So one VM, multi-purpose. That's called a Docker. So for the password, they gave the user this password. So it gets crashed now if I start running it because I have taken Ubuntu with a small GB, right? Small CPU. So it will doesn't work, but let's give it a try. That's all because of the setup. Okay, so you got the concept now, right? Everyone?
Yeah.
Yeah. So that is how the Docker works. So Docker can be installed in a physical machine or a virtual machine. So if you wanted to uh, use the Docker for a bigger purposes, so mostly people use the physical machines. So virtual machines, yes, it can also work. There is no impact. So now let me just recap what we did discuss here. It just only we discussed on the pull and the run part, right? So now, so what we did, so we have taken a virtual machine, right? We installed Docker on top of that, and then we started our containers, 3 containers, right? So this is your container 1 that has an Nginx, container 2 HTTPD, container 3 Jenkins. Okay, so this entire IP is same. So if I want to access C1 service running inside the container, I need to expose this on a port. So I have to expose this port here as well. So 8080, your OS will route the traffic. Okay, so your container will take everything from your host. So now remember, this becomes your host and this is the guest, right? This is a host, so this is actually hosting it, and this is the guest here. Okay, so now again, if you want to access container 2, so I opened an 8081. So 8081 I mounted to this container, and then 8080 for Jenkins, it goes to container 3. So you can control that part. Okay, this is what it is. Clear? Any doubts on this?
No.
Good.
Lokesh,
Yeah, go ahead.
capturing an image in Docker means this is the part. Mm.
Creating the image, you mean?
Yeah.
Yeah, we need to
Clear.
create the, yeah, we will discuss that as well.
That is
Creating the image.
different. That is different. This is different, right?
No, see, you have this image here, right? So you just installed it, right? You pulled it from here.
Yeah.
But who created that image initially?
Don't know.
So someone have to create this image, right? So
Yeah.
remember, even though in AWS EC2, when you want to spin up a RHEL machine, so someone has to create it, right? So since it's AWS, AWS take care. It's a Docker. These are all community people. So people who are very interested, so they prepare the Docker images and push it here. But if you have your own purpose, so let's suppose we have an Nginx here, right? So this Nginx is always giving me this, but you wanted to host your website. So how do you host your website? You want to put your index HTML file, not this regular one. You have to create your own image for that. So how do we create image that for that? What are the commands? What are the steps? We will discuss. Okay. So now let's do this. So now we discussed about the pull, right? And now we also know the run. Okay. So now let's see. So I just continue as it is. So I say Loki. So this is my Jenkins. So which is having 2.151 version, which is the old version. Okay. So here, if I create the job, okay, I create the job, it gives freestyle only. That's fine. So I would say my first job, freestyle project. Okay, save. And then I just save it. Let's say. So I have a job here, right? First job. This is my job I created. Okay. I run it and it fails, of course, or success, whatever it is. It succeeded because I did not add any steps over there. So now my Jenkins is up and running. Okay. All of a sudden, something bad happened. Okay. So my machine got crashed or something has happened. So this Jenkins container that is running, it got killed accidentally by someone. If I do docker ps, I don't have the Jenkins running. Do you see Jenkins over there? No. Okay, if I try to access it, what happens? I cannot because container died. That's fine. I know how to spin it up, right? It's easy. So we just need to run the command. So let me run the command. So name, I give a different name now because I cannot use the same name. I give this name, I run it. Boom. My Jenkins is up and running. If I do docker ps, it's running, same port. Now let me access. So it says starting Jenkins. Okay, let's wait for some time. Still starting. Let's wait for some time. Now let's pull the Docker logs here. Still pulling up. I do -f here. -f will tail. I think it says up and running. Yeah, it is up. But it is again asking me to perform the initial setup. This should ask only First time, right? Not all the time. Okay, I have a password here. I copy this and give it here. Maybe it's some mistake. That's fine. Again, it is asking me to install the plugins. You should not ask. Okay, I say install the plugin. It is installing. Something fishy is happening, right? That's fine. Let's see. So these plugins were already installed previously. Okay, I continue. It's asking me to create the admin account one more time. Okay. So it is your job. We created the first job, right? Here. Remember? But it's gone now. So it means if you had created thousands of jobs in the Jenkins and someone accidentally killed that job, killed that Docker process, your entire data is vanished. Right? So you have been working on this Jenkins that is running inside the container. You created jobs, you tested your jobs. So now entire Jenkins is gone. It's again like factory resettings. So do you like this then? Do you use it? In technical, in general terms. So you have a Jenkins running inside a container, that is a Docker, and whenever something got happened, your container restarted or it got killed and you started up. So entire data is gone. Do you like this behavior of this Docker?
No.
Why?
No.
Why?
Because we lost the data. It's like, again, we have to do it from the scratch. It's like, it's pain.
Right? Then why Docker is so famous?
Maybe it saves somewhere the data. I don't know.
Yeah. So Docker is like a process. Okay. Docker is like a process. So like in our VM, right? So whenever you run one command, like ls command, it executes a process in behind, right? That process is short-lived. So Docker is also a short-lived process. So if you want to run them in a long, then you need to run it as a service. I mean, you need to run a container service, right? A service has to be there and service should be running. Then only your Docker process will stay for long. Okay, that's what the Docker. So now we have a Docker processes that are running long. So this is up from 23 minutes, 17 minutes, 4 minutes. So whenever you run a Docker image, it always a fresh start. So whatever data you have stored inside that image is gone, completely gone. Now let's for example, I'll show this. I have Nginx, right? So let me kill this Nginx. Docker kill this Nginx. This got killed. Okay. So now let me create the Nginx one more time. So Docker run -p, that is 81, right? 80 81. Sorry, 80 Nginx. I need to run in -d port. So Docker ps. Now Nginx is running. Now let's log in inside the container. I want to see inside the container. The command is docker exec. Okay, -it, interactive and terminal. You need to provide the container ID followed by the command. So if you say ls, so this ls command will be executed inside this container. Okay, let's see. See, this ls is part of this container. So even again, container means it also has a OS, it also has a file system. This is the file system it has. Now let's do a curl. Let's see if it has a curl dash dash version. So this is the curl it has inside. Now let's do wget dash dash version. It doesn't have the wget because this container doesn't need wget, because as I told you, the image will only contains the required packages. So if I do docker images, docker images are going to give me the images that are available. You see, Nginx is just 133 MB and the HTTPD 138 MB, Jenkins 703 MB. So if you really wanted to run your application at HTTPD, you need a complete VM, right? But in this case, you don't need. You just download this, install the Docker, and run this. Your website is up and running, right? So now these commands are letting me go inside, right? So now, sorry, run the commands, right? Now I wanted to go inside. So here, other than an execute command, I say bash. Bash means shell. So this will actually take me inside the container. You see, where I am root at this guy. What is this guy? This is your container ID. Okay, so now I am inside the container. If you do host name, you see this is a host name. Do ls minus latr, this is a structure. See, it looks like another operating system. You can also go etc. So you have everything. Apt. So it's a Ubuntu one. Right? So now let me copy one file here. So I go back here. This is my home directory, right? Now let me create one file here. So let me see let me see first VI. See, they don't have a VI. Because VI is required to use resources. That's why they did not install it. You don't need for container, right? It is a VI. So now what I need to create a file, touch abc.txt. Okay, touch is there. So I created the empty file. So let me put something here. Hello world, no, hello container. So put this in the abc.txt file. See, I have some content. So let's read this. I have this. Okay, I saved the file. I came out. See, now I'm back to my VM, right? Okay, if I do docker ps, I have the Nginx still running. Now let's go ahead and check the file. I go docker exec minus it container name and the bash. So I go to the home directory. So I still have the file here. If I do cat abc.txt, still there. It is not deleted. So I come back. Now let me kill the docker process, because process is still running when I create it. So now I'm going to kill this process. Docker kill this guy. Done. Nginx is gone. Now let me create Nginx one more time. Same. Yeah, this thing, right? So I created again. I do docker ps. So same image, everything is there. Now let me access this container ID. Now it has a new container ID. Docker exec minus it. This bash. I go the home directory. I do ls minus latr. Boom. There is no abc.txt. It is gone. So this is the Docker. So once the process is died, that corresponding Docker process, then whatever files you have stored inside the image will gone forever. You cannot recover those. That is very dangerous. But how am I going to preserve my contents, persist my contents permanently? So whatever files I'm creating, whatever Nginx is writing, I want the data to be preserved. I don't want it to be deleted, right? So how do I do that? To do that, we need to use the volumes. We need to use the volume. That is called the mounting. Okay. Now let me do again Docker PS. This is my Nginx, right? I'm killing this. Docker kill this guy. Docker PS is not there. Okay. So now I'm going to create a directory called mk directory my data. Okay. I go inside the my data. I copy some contents. Let's maybe index.html. Okay, I have this data there, hello there, right? So now what I'm going to do, I'm going to mount this my data in the Nginx container. Okay, now let's see. So we know the Docker command, right? So Docker run minus p 80 colon 80 minus d Nginx. This is the command that we need to run. But here I'm adding minus v. It is called volume. Attach the volume. So whatever directory you have on your host, that is your VM, will now be mounted to your container. This is exactly similar to your tell me EFS. So EFS you can mount to multiple VMs, right? So you have once you create EFS, you get the IP address, or you get the location to access. Then you mount that inside your VM with the mount command. To make the mount permanent, you edit fs tab entries. Remember? Forgot? Okay. The same way with minus v. So now I am mounting. So what I am mounting, I need to mount this my data, right? So my data is here. My data colon, where you want me to mount? I want it to mount to /opt somewhere. Okay. Now let's see what happens. I give a space. Now let's run it. Okay, invalid characters. I need to give the full path. pwd here. Okay. So my data is actually available in /home/ubuntu/my data here. Okay, attached to this location. It got attached. If I do docker ps, my Nginx is running. Okay, now I log into this box, docker exec -it bash. So where I mounted inside /opt. See. So whatever data I created over there, it got created here. Index.html. So if you edit this, hello there. So if I edit this here, let's suppose I wanted to add some more contents. Edited inside the container. Add this to index.html. Okay, if I do, I have 2 lines here, right? I exit. Okay, I go to my data folder. I have a file here. If I see, so this is nothing but you are accessing outside data, outside directory in your file. So this. So this is your VM, right? This is your Docker, and this is your Nginx container. Okay, so what you have done here is, so you just created a directory here. Okay, you mounted this one to here. Okay, so whatever you write inside the container are actually getting stored in your VM, right? It's just like a mount, the same way as EFS. Okay, so if you edit inside the container, you can access in your host. So if you write something on your host, the same is visible here as well. Okay, so if something happened and it died, no worries. So what you can do, you can again spin up one more container and you mount same value here. Now whatever data you have, the same will be visible here as well. See, now perfect. So now even though my container dies, the data that container is writing is actually getting stored in my VM directory. And the same directory can be mounted multiple times to multiple containers at the same time. That is the beauty of this Docker. So even though my container dies, whenever I restart, I get the exact of what it was running before. No changes, nothing. Remember, that is what the volumes are used. Okay, so now let me go ahead and delete this and recreate this.
So here it will depends on volume.
Yes, this is the my data is a volume now. I just created volume in directory. So we call as a volume in a Docker terms. Okay, so now I have the Docker ps, right? Now I kill this. So before I kill it, you guys see it. So Docker exec minus it bash. I go inside the opt. I have this index files, right? Now I come out. Now I kill this. Docker kill. Container died. See, Nginx is gone. Now let me rerun the same command. Is same, right? I started the one more Docker container. So it appeared. Now if I access this Docker exec minus it bash, if I go to /opt, see I have same content. So that is how you preserve the data. So remember, so Docker containers are always ephemeral. They are not the, that doesn't store your data permanently. If you wanted to store the data permanently, you want to preserve the data, then you need to use volumes. That is called -v. So -v volume means you create one directory in your host, and then you mount that directory to your container by using -v. So now whatever you write inside the container are now visible outside. So whatever you do in outside are visible in container at the same time, because it's just like a link file, like a EFS, right? That is what it is. Okay, so now let's work on our Nginx as well. So we have our website, right? Now we have in the same way, if you want to work on the Jenkins, now let's store our Jenkins data permanently. How do we store it? So I'll go come here. I say Docker ps. I have Jenkins, right? I'll kill this. Docker kill. This guy is gone. Okay, get me the Jenkins command. This is a Jenkins command, right? So now let me run Docker run mine. Maybe I will create one directory first. This is my Jenkins home. Okay, now I'm going to run my Jenkins. So I think they provide me to do it in /var/Jenkins, I think. Yeah, this is the place. Okay, This is Jenkins home, right? So now the command is docker run -d -p 8080 colon 8080. One more -p 50,000 colon 50,000. Name I don't give. So now I need to use a volume -v volume. So this is my host. Mount it to /var /Jenkins home. I think this is what they said. Yes. Now I need to run the Jenkins CI /Jenkins dot latest. That's it. Now if I run it, it's mounted. So if I do docker ps, I have my Jenkins here, right? Let's see the logs. Docker logs -f. It is loading. I got the password. Now let's go ahead and access my Jenkins. This is my initial password. Install suggested plugins. So now this is my Jenkins up and running, right? Now let me create one quick job. Same job. First job, freestyle project. This is the old Jenkins, that's why it is. So I do the build step, execute a shell, echo load up. So if I run this, so data is there. Okay, my Jenkins up and running. So now let me check the Jenkins home here. If I go to Jenkins home directory on the host, so I see the contents here. But oh, it is not mounted properly. Oh man. What is the command I ran? -v, right? Jenkins home, mount to Jenkins home. Yeah. Let me just quickly verify where it is actually mounting the disk. Docker ex pc -it /var. Yeah, /var /Jenkins home only. Why it hasn't mounted the disk? Let me kill this one more time and give the complete full path. Maybe it would have taken the default path. Let me kill this. The same command one more time. This time I give the complete path. /home/ubuntu. Yeah, see, it got created now. It took the default one. Okay, so now let me do docker ps. This is the file, docker logs minus f. This is the password. Oh, it again did a fresh start. Okay, continue, let it fail as it is. Done. So my Jenkins is ready. Now let me create a new job. Sure, this will be a permanent job now. Build step, execute shell. I built it, so it is a one build is there, right? It printed. So now something is happened. Now let's kill the Docker process. So Docker PS. This is the Jenkins stuff. So let's go ahead and kill this. Docker kill. Then. So sorry, there is no Docker processes. So now let's run it again. Yeah, the same command, no changes. It's run. If I do docker logs minus f and this guy, it is giving me some exceptions. It's running at least. Let's see. Since Jenkins is fully up and running, so it is up and running. Now let's access it. So it did not ask me for initial setup, just asking me for user ID password. I entered. Come on. Yeah, see, I have my job as it is. Did I lose anything? No. That is how you preserve the content. Okay, so all the data is now sitting in your host at this location. So if you delete this directory on your host, then it is gone. So this is how you need to preserve the data. If someone accidentally delete this data, then you cannot get your Jenkins back. So it will be again a fresh start. So you have to recreate everything. So this is how you work on the Docker. So again, let's recap. So Docker is just like a process. So whenever you run a container, it runs as a process in your virtual machine or a physical machine. So all the Docker processes are short-lived, you can assume. The once you kill it, the entire data, whatever you have written, is vanished. So every time you start a Docker process, it is a new. So if you want to run a Docker as a long process, lengthy process, then you need to have a service running, and that service will make sure your process is always running. So like Jenkins, Nginx, HTTPD, all these will run the service, makes your Docker a lengthy process. Okay. So if you want to preserve the data, you need to use the volumes. -v is the option. -v volume, you mount your host local disk to your container. Now whatever you write inside the container is actually being written on your host disk, and whatever you write on your host disk is immediately visible inside your container. Okay, so docker run is a command to run the image. Docker pull is a command to download the image. So image, you use docker pull, so once you run it, it becomes a container. There's a difference. Okay, so image are available in Docker Hub. We can also build our own image, which we are going to discuss a bit later. So once you have your image ready, then you can run it. So once you run it, it becomes a container. That's the difference. Okay. So now let's
Lucas, I
quickly,
have a question. Sorry.
yes, go ahead.
So my question is, if we keep the Jenkins Homes in a Jenkins container, I mean inside the container, Docker container.
Mhm.
So if we delete the Jenkins, you think we'll be able to uh, retrieve our Jenkins by having the Jenkins Homes file saved in container?
No, you cannot save. So whatever you save inside the container is all temporary. So if you have saved the Jenkins home in an image, yes, then you can recover it.
Okay, thank you.
Yeah. So now whatever data is written in the image, right, that is permanent. That we'll discuss in the Docker file. Okay. Now let's check about HTTPD quickly. After that, we'll be done. So where's the HTTPD? Where is the HTTPD? HTTPD. Here it, right? So we wanted to build our website, right? Come on. Maybe let's open Nginx itself. See, there is a limit they have put on the Docker Hub. It may take Nginx. Why it is so slow, my machine? So this is Nginx, right? So this is how you run. So now we know the -v volume, right? So I'm going to mount my index.html to this Nginx. Okay, so let's go ahead and run this. So I have my Docker PS. This is my Nginx, right? So currently running on port 80. So if I access this on port 80, I'm getting this. So now let's write my own index.html. I go to my data. I have index.html here. This is not index.html. I'm going to write HTML. What do you call body? Just write plain one. H1. Hello Docker. Use image as well. It's good to use the Docker image source. Hi. Docker logo. I'm going to inside. Okay, this is my HTML, right? So I'm going to mount this. So Docker run -d -v /home/ubuntu my data mounted to this location. HTML, right? And what is the Nginx is the thing. The port is -p. Already 80 port is being used, so I'm going to use it inside the 8082 mounted to 80. Simple. Now 8082 is also working, right? Now let me access my application on port 8082. See, this is my Docker. This is the default Nginx that they have given. I override that with my stuff. Same thing. So I can also add immediately. So if I go ahead and edit the, why image did not come? So image is not coming, right? So let's go ahead and fix it. So image, sorry, source equals to, not colon, I think. Yeah, source equal to, this is the source. Now I save this. If I refresh it, boom, because whatever I edit outside on the host is immediately visible in the container. So that's why the container was able to serve it. So I can also edit outside. So rather than hello Docker, I can also add some stuff. Refresh it, boom. So, but this is constant because this is coming from the image. This is permanently stored. This is temporarily stored. And this store contents is available on my host. Even though this container process died, I can still able to recover my website. So you want to bring one more instance easily. So you have the same command, right? So not 8082, 8083. So now my website, now another instance of my website, 8083. See, so 8082, 8083. So it means you launched 2 containers. Like in your load balancer, if you talk about, so we install HTTPD in one machine to make it more what do you call, high availability. If one VM goes down, your application should be running from another VM, right? So we install same application in another VM and you put a load balancer. But here, this is one machine, this is one instance. So you can bring as many as you want. So you can load balance it. So if you edit the contents here, so I save this, you refresh it, see, boom, refresh it, boom. So that's what it is. So your container has just Nginx softwares running and you have to provide where your HTML file is. So in a company, we just talk about where is my jar file. If you are using a Tomcat, we just install the jar file and we run it. See, now I can run as many times as I want, as many times as I want. That's the beauty of Docker. Clear? Any doubts on this so far? Guys?
No.
Sure, right? So I think we are good for today's Docker. I would recommend that you guys at least have some practice on the Docker because further topics are completely on the Docker only. So we are going to use the Docker to run our Jenkins. We also use Docker as our build agents. We also use Docker and then we work on our to create our application for our microservices. Let's suppose we build our application and we put it inside the Docker image and then we run it in a Kubernetes. So I would recommend that you pay attention on the Docker stuff. You at least practice whatever we have done so far. And after that, Kubernetes we'll discuss.
Hey, Lokesh, one question, sorry, before you go.
Go ahead.
I'm still very disheartened about Docker because if you kill the server, let's say Jenkins is running on that server, container, and the Jenkins will just be gone. I mean, everything will be lost. There should be a way to prevent that or make it work even if we kill the container. When we start the Jenkins, it has to come back on. I'm not sure how, but there should be a way. I'm just a little disheartened about the.
We have minus volume, right? We use the minus V volume because of that.
We use the minus V to mount our folder directory, right, Lokesh?
Right.
So did that, save us from losing the Jenkins itself?
Oh, you mean to say, okay, so the minus V volume will preserve the data. Okay, will preserve the data. That is perfectly fine. So even though this container dies, if you run the same command, it will again bring it your Jenkins to previous state, whatever it was before dying, right?
Okay.
So that is covered. So why the Jenkins process gets died? There are various ways. So maybe some resources are having some issues, and maybe Docker process got some problem and it had to restart it, or maybe someone accidentally upgraded the Docker version and then it had to restart all the containers. There could be various ways, right?
Right.
So
Okay.
if Docker process died, okay,
Yeah.
then we need to know why it is died, and we need to know someone immediately start it, and they should know what command they have to run. So by accidentally, if they miss -v volume mount, then again Jenkins will do a fresh start. So all the data is not visible. So they may go panic. So someone should know that this Docker should be run with -v parameter and this is the ports. So you have to have documented, right? It's a bit
Okay.
of a
Yeah.
pain.
Much clear. Thanks.
Yeah, it's bit of a pain, right? To do all this. So what if there is a tool that take care of all this? So you don't need to worry. You just give the instruction saying that this is the port, this is the volume, this is the image, and it has to run always. Then that guy will take care of make sure that you have this always Docker process running. The moment the Docker process dies, it will automatically restart with same options.
Okay.
That
Thank
is
you.
called the Docker orchestration. That is what Kubernetes and Docker Swarm does.
But my question was mainly on the Jenkins part. When it was deleted and we lost everything, we had to recreate, Jenkins and follow the same process again, create the user and plugin and install plugin and build the jobs.
That's why you don't need
Yeah.
to do that. So if you use -v parameter, right? So let's suppose we are using
Yes,
-v
yes. So
parameter.
what I mean is that the parameter v, I now understood it fully because it can prevent users to delete Jenkins or any files accidentally.
Oh, you mean to say files got deleted when you're running the Jenkins?
Yes, when we create Jenkins in a Docker container and then we accessed it, and then we accidentally, you killed the container and then all the Jenkins was gone, and then you had
No,
to create everything.
no, that's what I'm saying. So Jenkins will not gone if you use -v parameter.
Yes, yes, clear.
Yeah, -v parameter. Yes.
I think
Okay.
what he is trying to say, like what he is trying to get is like -v parameter is like using a pen drive. You have your backup. It's just a backup. It
No,
will.
it is not a backup. This is how you actually run it, because it is Jenkins. Or if you take any image, so image whatever while creating, whatever data they have put, they're all permanent. So when I create this image, right, so they might have copied the Java, they might have copied the Jenkins var file, right? That's it. And after that, whenever I run it, whatever they have copied preloaded, this will be permanent. Now when the Jenkins is run, it gives you some flexibility of creating the jobs. You create the job. So when you create the job, where it is going to store, it has to store on a disk. So it by default takes a local disk that is in the container. So container died, so it loses all the data. Again it go back to its preloaded image. So when you bring it up, it's again a fresh start. So if you want to preserve that data not being loose, we need to use -v parameter, and we need to know where Jenkins is going to store the data. So in this Jenkins, it will store the data in this location, whereas Nginx, it will be /var HTML directory. So that will be available in the documentation. So now what I did, I mounted my local volume to the container inside. So now whenever Jenkins is up, is running, it creates the jobs. So that job will be written at this location, and this location is mounted to this place, which is host, right? So data is here. Now whatever Jenkins is writing, everything is here. Now Jenkins died. You started. So Jenkins start with its preloaded data. So now Jenkins sees, okay, it looks like there is some data already available in this location. So now I'm going to consider this data and start the Jenkins. So when the Jenkins started, the data which is stored here will be considered to launch again. So since your user configuration, your plugins, jobs are already configured, they will appear as it is. There is no issue in that.
And like another thing I was wondering was, like, we did Nginx and HTTPD. Like, we have two things, right? Two applications. Now, both of those will need index.html, right? So when we mount those index.html file in the same from the same location to both of those, and what happens is both of those will make change independently, and how it's going to work with that our mounted file. Like, if they are using common resource parallelly, and like, is it going to work same as like Git?
Like, so if you had practiced the EFS, right? So we have taken one file disk and mounted to two machines. Okay. So if I edit in one machine, the same data is visible in machine 2 as well, because they are retrieving the data from one common source.
So will
The
it
same
work
way here.
exactly like EFS?
Yes.
Okay, now my another doubt will be, what if, like, how can we prevent to, like, if someone doesn't want to implement on both things like HTTPD and Nginx, but because we have mounted in the same place, the changes will reflect on both. Now,
Right.
what will you do if you don't want that? Like, if you don't want to change that reflect, do you need to create like another index.html file?
Yeah,
Or,
you can create as many as you want. So this is our use case. So in my use case, Jenkins home is separate, my index is separate. So that's why I created two different directories here, my data and Jenkins home. So if you think the same Nginx, I want to have multiple different index HTML files, we can create as many territories as you want and mount the corresponding ones. Like for
yeah,
container 1, you use this folder. Container 2, you use another folder. Container 3, you use another folder.
so this one works exactly like EFS.
So in, let's say about Docker PS, right? So now I have these instances running, right? 81, 82. So now let me talk about C. So I wanted to create my Amazon. Okay. I copy my data index.html file to here. Okay. I go to Amazon. I go to index here. So this is not the, I'm just going to change the Amazon logo here. So this becomes my Amazon site. Okay. So now I go back here. I create one more directory, make dir Facebook. Now I copy my index file. It means creating a new one. Okay. I go to Facebook. I edit the index file here. So in this time, I'm going to take a Facebook logo. Now I come back here. So now the same command, docker run -d, right? -p 8084 mount to 80. You give a name, machine name that is called Facebook. Okay. Now you bound the value /home/ubuntu Facebook mounted to slash var. What is that file? Share image HTML. USR share Nginx HTML. And what is it? File name is Nginx. This is done. So now I do the same thing here, but I'm mounting Amazon. So this container name is Amazon. So the port is, I'm going to use different port, 8085. So if I access my website with port 8084, I get Facebook. If I do the same thing with port 8085, I get Amazon. So it's all about how you are managing the data. So if you want multiple instances of Amazon, right, then what you need to do, you just have only one Docker process at the moment, right? For Amazon, you are running only one, which is Amazon name. So you are running only one instance of Amazon. So if you want to run one other instance of Amazon, you can simply say, change the name here. So use the same mount, Amazon 1, change the port to 8086. So you can also access same thing with 8086 as well. So now you have two instances of Amazon running, one instance of Facebook. So you successfully built two websites in one VM by using Docker. The thing is, why do we share same volume pound to Amazon is because these two containers running for one website. So whenever the connection goes to this one or this one, the content should remain same, right? If I log into this box and delete the Nginx index.html file, my entire website is gone because the actual source will be deleted so that this cannot access, everything is gone. So if I edit something in my host, then this guy can see, this guy can see the changes, and then they load the data.
Lokesh, I think it's a great way to, or it's a great approach to have a stable website running for, as you said, high available. So this process is still a static process, right? It's not fully automated yet. So the Docker can vertically or horizontally increase the Docker container itself instead of making it more static. But it is a good approach. I think it's a static one. I'm just I just have concerns. Which one is better in your way? Fully automated, or just to keep it still available, but to take good approaches, but still a static approach rather?
So, yeah, this is all the basics. So this is how the basics of the Docker, or this is how the Docker works, right? So now on top of that, to automate all these and manage things effectively, now perfectly fine. So you have 86, 85. So if I want to access my Amazon.com site, so do I need to use two different ports here? No, right? Only
No.
one port. You always give Amazon.com, then based on that, it will spin up. So now you just have only two containers. Tomorrow, many people access it. So load is high. You need to spin up few more containers. Then who is going to spin those up?
Right.
And also the process got died. Then who is going to start it automatically so that it will get back to the previous state that before dying. So all those will be taken care by a tool called Kubernetes.
Okay. Yeah, makes sense.
Kubernetes will come to the picture to orchestrate your Docker containers. So that will take care. So now you have only one machine, right? So what entire machine is goes down. So you will lose all the containers, right? So you have to have another VM running. So who will take care of that? The same image running here will also be running in another VM. Now who will take care of that? The traffic is properly managed between these two VMs. Now your VM1, yeah. Yeah, those will be taken care by your Kubernetes.
Okay.
Yeah, so that's why. So first you understand the basics, how the Docker works. On top of that, the understanding Kubernetes becomes easy. So if you don't know how the volume works, you don't know how the ports are work, then Kubernetes makes you a bit tough to understand all this.
Okay, thank you, Lucas.
Yeah. So any more questions?
Yeah, one more.
Go ahead.
Okay. Is there any cases like if two people will if two people can change the host file, for example, the index.html file at one time, two people will try to make, or is there any chance of conflict in changes if someone tries to do that?
Whoever saves first, thus changes will be there.
Okay.
Yeah.
So, I don't know if it's the right way to understand or not, but I'm trying to like compare it with like Git and our EPS. So I don't know if it's the right way or not. I was thinking, what if like two different like people will try to change the same index file, and what will happen?
Yes. So the thing is actually, this is like the layman terms, the complete skeleton of the Docker, how it works. But technically, you don't edit the files directly. So we don't just to make you guys familiar how the Docker volumes works, how the Docker works, how the expose works, how the ports works. I have shown you the basics, the pure skeleton of the Docker. But we generally don't do all the edits. So Kubernetes will take care of everything. We just provide the instructions what to do, and it will take care of doing everything.
Yeah, makes sense.
Yeah. Okay, so that's it for today. So tomorrow, I think many people are not available. So let's take off tomorrow. So I would highly recommend that you guys definitely go ahead and practice this, whatever we covered today. If you don't practice this, if you don't make yourself comfortable with this Docker, then understanding further topics becomes too difficult. Okay, so next class we are going to discuss on building the image ourselves by Dockerfile, and then we are going to use it as a build agent in our Jenkins. So I would highly recommend that please practice this without fail. Okay, good. So let's catch up then next week. So next week is what? Next week is again New Year, right? Okay, let's discuss. We'll ping in WhatsApp. Okay, we can check. Good guys, then. So have a nice holidays. We'll meet again tomorrow. Not tomorrow, sir. Next week. Okay.
Lucas, have a good
Bye,
week.
guys. Bye. You too. Bye.
Bye.